This video is sponsored by Koala Naturals. Koala Naturals provides you with a high-quality, all-natural lye soap that is free of any harsh chemicals, additives, preservatives, or artificial colors. Koala Naturals Lye Soap is gentle and sensitive skin, but tough enough to clean the dirtiest of hands. Use Koala Naturals Lye Soap to clean your counters, dishes, clothes, and even yourself. Pick up your bar of Koala Naturals Lye Soap today at koala-naturals.com. Link in the description. Now back to your video. Okay, so I got the new tubes in today. Let me try and show them on the camera here. These are the new tubes. I've not installed them into the guitar amp yet. First, we need to replace, just a direct ground connection with the cathode resistor and, the bypass capacitor. So I'm going to be using a 450 microfarad capacitor. And then I've got this resistor here, this 240 ohm, which I'll be using on the cathode. Ideally, you'll want something around 2 watts for the cathode resistor, which, if my understanding of these resistors is correct, I believe that this is a 2-watt resistor. So I'm going to go ahead and I'll solder those where the ground connection is, and then I'll attach the bypass capacitor as well. And then, of course, we're going to have to rebias it at that point too, which I'll show that here in a second as well, how that process is done. So looking through my stash, I did not have a 450 microfarad at an appropriate voltage, so instead I'm going to use a 220 mic at 25 volts. That should be plenty enough for the cathode capacitor. Okay, so I got the cathode resistor and the bypass capacitor installed right here. That's the resistor, and that's the capacitor, kind of hiding behind this resistor here. And the other tube, I got a ground wire connected from the cathode of that to the cathode of this tube as well, and it's just going through the same cathode resistor. So I'm going to power this thing up now. I need to check. I'm going to be hooking up my multimeter to the grid of these tubes, and I'll be checking the bias voltage, and I'll be adjusting it to probably about negative 23 volts, just for starters. And then on the output, I have this 8 ohm resistor here. 8 ohm, I forget exactly, I think it's like 20 watts. 20 watt resistor on the output. What I'll do, first I'll get the bias voltage set up to about where it should be at first, just generally above cutoff. And then what I'll do is I'll hook up my scope to the output, just hook it up across this resistor, and then I'll inject a small signal, about 1 kilohertz, small amplitude signal, and I'll adjust the bias just to make sure that there's no crossover distortion, that both tubes are biased equally, and that they're both pulling and pushing in the way that they should be. So let me get things plugged up. I'm going to bring it up on the variac slowly. I'm pretty sure that nothing is shorted, but I just want to be sure. I don't want to shoot the juice to this thing and then blow a transformer or something. So I'm going to connect this up. I'll get my meter out. I checked on the front and it's in standby, so there shouldn't be any V plus on the plates, but it should still be providing bias voltage, even in standby mode. So I will go get my multimeter and I'll be right back. Okay, so just a quick note: when you're measuring the grid bias and you have the cathode floated up, kind of like what I do with that resistor and capacitor, when you're checking the bias, you want to ground your meter to the cathode itself. If you ground it to the chassis, your grid voltage isn't going to read right. It's going to read either 0 or positive. So the way I'm doing it, I just got it clipped onto the cathode of the output tube here, and I'm just going to go ahead. I'll put my meter on the grid, and then I'll bring this thing up on the variac. I already turned this thing on a moment ago, and it didn't seem to cause any major problems or anything. Watch me eat my words here in about 2 seconds. Okay, so it's still coming up. It's going to take a minute. Okay, the voltage is going positive on the grid, so that is not a good thing. We do not want positive volts on the grid. That's going to cause the tubes to red plate if we do that. Yeah, so I've got this unit. I just cut the voltage to it, so the voltage is going to drop off here. So like I was saying though, we'll want to adjust this pot until we get a negative voltage reading. So let me go ahead and get this clipped on as well. I'll get it clipped onto the grid. And then we will go ahead and adjust that bias pot and just get the grid bias dialed in here. Okay, so I'm really writing the short bus today. So when I was checking that bias earlier, I was checking on pin 8, and I saw it jumping up to about 100 volts, and I was like, that's really high. We got a short somewhere. So I'm looking through the circuit, and I'm trying to find like a shorted capacitor or some short between a resistor or something, which I did find one. Let me focus in on it here. That little red one right here. I replaced that capacitor. That's a new capacitor. The one that was there was testing about 4 meg, so that one had to go. But I replaced it. I'm still looking through it. I checked resistance between the B plus and pin 8, and it was like 1.5K. So I'm still hunting through the circuit trying to find out where the short is, and it's like, well, wait a minute. That is a control grid, right? Nope, that's a screen grid actually for this tube. It's the tube is a 7591, and on that tube, pin 8 is a screen grid. So of course the voltage is going to be 170 volts or 300 or however much. It's going to be high voltage, of course. It's a screen grid, duh. So the control grid, I think it was pin 6. It's this pin here. One with that resistor going off, and it's that one too. And I powered it on a moment ago, and it checked about -9 volts. So I'm going to go ahead and just let it power up this time, and we'll see what it biases up to once it's warmed up. Okay, let me get you set up there. As you can see, it's at 0 volts. I need to plug the unit into the variac, and I'll turn it on. Oh, I forgot. speaker in. Hold on. Let me get my dummy load hooked back up. Okay, take 2. Okay, so it's about -3 volts when it biases up, when it comes up. So that's obviously a bit too high. Let me clip this on here. Clip my probe lead on. And then we will get in and we will adjust that down. -18 volts really should be good, but I'm going to try it at its lowest first and then we'll go up. Yeah. Situated. Okay. And then not shorting. Close comfort. Okay, so right now I got my screwdriver on the bias pot. I'm going to bring the variac up. And then as we're doing that, I will so right now we're at, whoa, hold on. Bring that back down, we were at 23 volts before. Okay, so this is about where we were at before, so I got that biased up to a coarse value, and then the next step here is I need to get my signal generator taken out from behind there. I'll hook up the scope, and then I'll go ahead and I'll fine-tune the bias just until there's no further distortion in the audio signal, assuming that there isn't already. Okay, so I've got everything connected up here. I've got the signal generator connected through the cables to the input. I'm just going through the regular input, not the effects input. So right now I'm just going through the regular input. And I've got the scope hooked up on across the speaker output. I've got the speaker box connected as well. The signal generator is set to 1 kilohertz, and the output level is about 50 millivolts, which if I'm not mistaken, that should be the audio level if you're playing your guitar rather softly. It's been a little while since I've played guitars, so I'm not exactly entirely certain if that's the correct level for that. Let's zoom into a scope there. And I'll get the brightness adjusted so it doesn't blow out on the camera. And never mind those little spikes that you see. And there goes my alarm clock. Never mind those spikes that you see, that's just from the noise here. So let's go ahead, bring up the voltage on the variac. Okay, the reason we aren't hearing anything is because I have the volume turned down. So, oh, I have the thing on the wrong side. There we go. Hey, we have sound. As you can hear, the control is still a bit crusty. Okay, my bodacious body has been in the way this whole time, hasn't it? Okay, let me give you a better view here. This is across the speaker. And right off the bat, I mean, that signal looks pretty good to me. I don't see any crossover distortion or anything. Mind you, I got the attenuator turned it pretty good on that. Okay, let's try out the effects channel and see what that does. Okay, so this here is the Tremolo Circuit here. That's the oscillator tube. It's using a 6AV6. Anyways, these are the capacitors that are in that circuit, as you can clearly see. I checked these two. They're good, but the one behind it, let me show you. It is leaking about 10 volts. Just prove to you that I am checking at that capacitor. And we got about 10 volts leaking on that one. And that's a capacitor from the anode that goes between the anode and the capacitors here. Let me show you the other two capacitors. I'm not really getting any leakage on those. This is the first one and this is the second one. Yeah, there's no leakage on those. It's just that one capacitor that's on the B plus that's leaking about 10 volts. And yeah, you see this wire here too. That just goes up to that pot, which is a resistor to ground. So it's not like like there's 10 volts coming in through that pot. That's a resistor to ground. There's no B plus on that pot. So that capacitor, that one right there in the back, that one is leaky. I just brushed my hand up across a 300 volt line. I didn't get shocked, but that's what that jolt was. Anyways, I'm going to go ahead and replace that capacitor in the back, and we'll see if well, the tremolo is working now. I had to replace those two orange capacitors. The ones that were, the gray ones that were originally there were. One was shorted and the other one was open. But we seem to have a working tremolo now. But we're not completely out of the woods yet. You see I turn that down pretty much all the way and it just squelches it. It shouldn't squelch it like that. And then to get it back, you gotta kind of fiddle with it a little bit. It'll start to oscillate and you'll hear it a little bit in the audio. But if I turn the gain up too much, it squelches it. If I turn it, obviously if I turn it down, it'll come back. So we still have a problem elsewhere, but the switch seems to work. The oscillator seems a bit slow to start too. That's not the right control. And it seems like I can kill the oscillator too if I change the speed of it. So there's still a few more things I need to look at. So that was an interesting sound. There's still a few more things I need to look at here. But, I mean, the oscillator is running now, but there's something else going on in the preamp. I think it's the preamp section. I'm not entirely sure just yet. But, yeah, the tube seems to be okay. The oscillator tube is okay. The output of this tube goes to the output part of the input amplifier. So it's going to the cathode, as you can see down there, and then it modulates the cathode, and that's how you get your tremolo effect. But I want to check that tube and maybe check some of these capacitors as well if those are leaky, and just see what's going on there, what's causing that to drop off. Because again, I don't think it's anything in this circuit that's doing that now. Okay, so I just got the tremolo working on this here. It does take a moment for the oscillator to start up, so I just turned it on now. And as you can hear, it is running. When I turn it up all the way, it doesn't completely squelch the oscillator either. And what I did to get that fixed was, let me shut this off and make it a little bit safe to handle here. I did to fix that, this capacitor that's going between, the cathode is pin 2 and pin 5. There's a capacitor on that tube that had shorted. This was the capacitor that was originally there. Let me get oriented. There was a capacitor that was originally there at 20 mic at 15 volts. And when I pulled it and checked it on my multimeter, I was reading about 300K of leakage current. Well, 300K ohms resistance, so there was some leakage current on it. And that's another 6 AB6 tube, so it's going from the cathode to the diode. I'm not sure exactly why they're running it like that, but they are in this case. So anyways, I put the new capacitor on there, and that seems to have cleared that issue up. Next things I want to check, I checked these two capacitors before, and they're okay, they're not leaky. I'll check these, I'll check all of those. That one's okay. I want to check the power supply capacitors as well here. That, and then there are two on the bottom here. This one, and then that one in the back there. And I'll check that 50 volt capacitor as well. But yeah, at this point, all the functions of the guitar amp are working now. So yeah, I'll go ahead and I'll check those, and then I'll get back with you as soon as they've been checked. Okay, so I just finished checking over the power supply, and the capacitors in here are still good. There's no more than 200 millivolts of ripple with the volume wide open. I checked over the rest of these, and all of them except that one there in the middle, that 20 microfarad at 15 volts. All the rest of them are good. The reason I say this one is bad is because you can see it's kind of oozing out the side there. If this thing would focus, that'd be nice. There. Isn't modern technology amazing? Okay. Yeah, you can see it's oozing out the side whenever this camera decides to focus. So I'll be replacing that capacitor, and then that's pretty much it. I'll be wrapping it from there. So that's basically it. If you have any comments or feedback, please let me know in the comments. And until next time, goodbye.